So Surya, that is what that is the chapter name. Whatever you send, that is what is solid, liquid, and gases. Okay. So
I think it's properties of solutions, right?
yeah, let me check. Let me check.
Yeah.
Today actually that was too much busy. Hectic schedule was there. I visited here in
Oh,
Varanasi. Do you know Varanasi?
yes, yes, I do.
Yeah. So I came here in the Varanasi. So that is why. So, okay, properties of solution. I have seen that one on the way I was in the car. So I seen that one. So when you talk about the, sorry,
Mhm.
solution, right? Solution. Let us have a look over the solution. So solution, if you talk about that is this is the homogeneous mixer. That is keep in mind. This is the homogeneous mixer. Solution means homogeneous mixer. Okay.
Mhm.
Now, that is what the word is here. We are talking about the mixer. So let us have a look over this one mixer. Okay, mixer. Mixer means what? No, mixing two or more than two compound. That is mixing two or what we are going to do two or more than two compounds. Okay, that is what that is mixer. Now, students, when you are talking about Surya, this one, the mixer are two types. You know, before going to the chapter, I am just going back here. So mixer are two types. First one is that is heterogeneous. Heterogeneous. This is the heterogeneous, and second one is the homogeneous. Homogeneous. Now, if you talk about heterogeneous and homogeneous, heterogeneous that is known as colloid. This is what known as
Mhm.
colloid, and homogeneous that is known as what solution. This is what the basic difference. From here we have to pick up the chapter. Now you see, hetero means that is different. If you know that is hetero means different. Hetero means
Right.
different. Okay. Genus means phases. It can be okay. Genus means phases. It is not going to mix here. Okay, and homo means same. Homo means it is going to be same. So homo means
Mhm.
same. It means let us try to understand. Homo means same means suppose you are making the sugar solution. If you are making to the sugar solution. So what you will find that is you will find that is in the sugar it is the container. If it is a container, so and that is the water is there. So if you are mixing the sugar here, if you are mixing the sugar, so what you are going to find, Surya, that you are finding that is whether you are taking from the bottom or taking from the top, the concentration will be same. Concentration will be same. I know
Mhm.
concentration same throughout. Okay, throughout. So if the concentration is same throughout to the system, that is what is going to be homogeneous. Got it? Homogeneous means
Yes.
same concentration. You can understand same concentration throughout. Okay. So that is what we are going to. If you are talking about heterogeneous, suppose I am having the rice. Okay, rice. So in the rice, suppose this is the quantity of rice we are having here, rice. And what is some stones are there? Here is some stones are there. So it is obvious you will find that is stones will be in the bottom more. Stone will be
Mhm.
bottom more. Okay, it will go bottom more. If you, I don't know if you wait or not. When you are cooking the rice, okay, when you are cooking the rice, so people, okay, generally eat from the top and bottom they left out because there may be stones. Yes, yeah, no. Okay,
Yeah.
there may. So what is this, Surya? That is what is known as heterogeneous. Heterogeneous means the concentration distribution will not be same throughout. Getting my point?
Mhm. Yes.
That is, we are not going to study the colloid. Colloid may be in the same chapter later on. Maybe definitely will be in AP syllabus is there colloid. But here we are talking about the homogeneous. So homo
Mhm.
means the same concentration. If you are making the solution of salt, you are mixing salt in water, you will find whether you are taking from the top, you will find the same salty water. If you are taking from the bottom, same will be there. Always you will find same. It's mixed in such a way, it get mixed in such a way that it form the homogeneous mixer. Got it? So let us try to understand again, come back to the previous page, what I means to say. Solution means homogeneous mixture of two component. Okay, two component. Acha, the things what I want to tell you, in our syllabus, it is binary solution. Okay, this is the binary
Okay.
solution. We are having the binary solution. Binary solution means what, Surya? Binary solution means made up of two component. Made up of two component. You know, binary solution means made up of two components. Okay, so two components, what will be there, Surya? That is two component. One component I am talking about solute, and another component I am talking about solvent.
Solvent.
Okay, solute, if you are talking about, it is always a small quantity. A small quantity. It is going to be a small quantity, and it is going to be large quantity. Okay, up now.
Right.
Large quantity. Now the things when you are going to keep in mind, what you are going to do, the solute will be what? The substance which is going to dissolve. Yes or no? So here I am writing that is the substance. It is going to be the substance which is going to dissolve, which is going to dissolve, the substance which is going to dissolve. Yeah, yes or no?
Yeah.
And here,
Yeah.
if you talk about the substance, here they are saying the substance in which they are saying the substance in which solute dissolve, the substance in which solute dissolve. This is what the point. Okay, the substance which is going to dissolve, that is what is known as solute. The substance in which solute dissolve, that is what is known as solvent. And the major point which we have to keep in mind, that is, it is will be always a small quantity and it will be the large quantity. Solute is always small. Now I'm writing one of questions here. No, which will be solute? Which will be solute? Which will be solute? Their question they are asking, which will be solute? 2 gram, okay, 2 gram NaCl and 2 gram NaCl and 100 gram H2O. So if they are asking that is out of this, which can be the solute, which can be solvent, which can be solute? Can you tell me?
So NaCl will be solute and H2 will be solvent.
So this is the what is this is going to be solute and this is going to be what? It is going to be solvent. Okay. So I'm writing very okay. So now what we are going to have another point here, another point, what the point which we are supposed to understand. Note, I will write in the form of note. Let me write note. NOTE. The physical state of they are saying the physical state of hello. Sorry,
Hello.
audible? Yeah, audible.
Yes.
Yeah, sorry na, because some call came and that is network gone. Okay, by mistakes.
Okay.
Okay. Now what the point they are saying already I think all deleted. Okay, we'll be able to write more and or else I already recorded, so I'll send you. So shall I write again or the recording will be okay for you?
Sir, I can't hear you clearly. Your voice is cutting off a lot.
Voice is cutting. Wait. Network is quite okay. I don't know. Now is it okay?
Yes, it is okay now.
What I'm saying, can I write again something or the recording already I did that will be okay to you?
Yeah, the recording is fine, and I think I understood the concept with NaCl and water. NaCl will be the solute and water will be the solvent, right?
Okay. So second, no, I am writing the note. Okay, you can make the note, okay, simultaneously, anything if you want to write. Okay, so if you are writing note, the physical state of, they are saying the physical state of what? The physical state of what? That is the solvent. Physical state of solvent will determine, will determine, will determine what? Something is problem. Sorry. the here is
Yes, sir,
Dwarasi.
maybe you can try turning your camera off. That maybe help your network.
No, no, no. What you are saying?
I said you could try turning your camera off. Maybe that would help the network.
Network is okay, it's showing, but network gone, disconnected.
Oh, okay.
Okay, but
Oh, now it's
if you are saying, let me turn off, we'll check if it is helping us. But here is the option. I'm not able to. Okay. Hmm. They are saying the physical state of what? The physical state of solvent. This is the node. Physical state of solvent will determine what it is going to determine. The physical state of solvent will determine, DETER, will determine the physical, types of solution. You can say the types of solution. Types of solution means nature of solution. Types of solution means nature of solution. Okay, that is what we have to keep in mind. So they are saying the physical state of solvent will determine the types of solution. Case one. What is the case one? If the solvent is solid, if the solvent is solid, if the solvent is solid, okay, then what will be then? Solution solution will also be which form? Solution will also be which form? That is solid. I know if the solvent is solid, solution also be solid only, right? So this is what the point that you need to keep in mind. Second point, what they are saying, case number two. Case number two. Suppose if in the case number two, if the solvent is, if the solvent is liquid, if you are talking about the solvent, if it is liquid, if the solvent is liquid, then the solution will be, then what will be there? Solution will be what type? Will be solution will be also, no, it will be the liquid state. Okay, that is what I am saying, that is physical state of solvent will determine the types of solution. Are you be able to understand this one? If the solvent is solid, the solution will also be solid. If the solvent is liquid, the that is the solution will also be liquid. If last case, if you can go, that is case number three. That is if the solvent is gas, okay, then
Mm-hmm.
can you guess? Then the solution will be
It will also be gas.
solution will also be gas. So this is what we have to keep in mind. So can I change this one? Can I remove this one?
Yeah.
Okay. The point number two. Let us try to write the point number two. What is that? Is next point, that is classification of solution. Classification of solution. If you are doing the classification of solution, that is going to be 9 categories. Solution are total 9 categories. Okay. So what are the 9 categories? Based on, they are saying 9 categories based on what? Physical state of, based on physical state of solvent.
So your voice started to break up again.
Okay. It's getting something correct. Now it may be clear. Is it okay?
Oh, it's better now.
Huh.
Yes.
I came, sorry for disturbance. I told to sir, can you schedule that is the Monday also? But
Yeah.
so when you're talking about this one, there are 9 categories are there based on physical state. Okay, based on physical state of solvent. Total 9 categories are being formed. Okay, total 9 categories. So let us try to find out this one. So first one we are talking about solute. Okay, then I am taking solvent. Okay, solvent. And last one is nature of solution. This is going to be what? Nature of solution. And last one, that is examples. Okay. So type 1, suppose it is the solvent I am taking, that is liquid. Okay, solvent I am taking, that is liquid, and here again I am taking the liquid. Okay, here I am taking, that is solid, then I am taking liquid, then I am taking gas. Okay, so since the solvent is liquid, so this all will be what, all the three categories solvent will be, it is also will be the liquid solution will form. It is going to be liquid solution. Here also it is going to form what, liquid solution, and this is also going to form what, that is liquid solution. Okay, this is there. Now see, solid dissolve in liquid, so it is forming liquid solution. Like example, that is what, NaCl dissolve, where that is dissolve in water. Okay, so water means, that is you can write, that is salt solution. Yes.
Okay.
So
Yeah.
if you make the salt solution, Surya, so can you find out any of the salt particle? You won't be able to find the salt particle. It
No.
will completely dissolve. It will completely dissociate, because iron and hydrogen bonding, iron and dipole attraction will be there, ion and dipole, because Na and Cl, I told you there earlier, that is Na plus will be there, it will attract the no, O minus of water molecule. Here is O minus, so it is going to be completely dissociate. So that is what this is forming the homogeneous solution. So this is what solid dissolve in liquid, that is NaCl dissolve in H2O, that is salt solution. Second example, example number 2. If you are talking about example number 2, that is sugar solution. Have you seen the sugar solution?
Yes.
The sugar is in the solid state and water is the
Yeah.
liquid state. So what kind of it will going to form? That is liquid solution. Okay.
Liquid solution.
Uh-huh.
Yeah.
Next categories is there, liquid and liquid. Many more examples are there. Many more examples are there. We are going little bit. Okay. Next case. Next case. If you are going next case, what is there? Liquid, liquid. So if you are forming liquid, liquid, so that is alcohol in water.
Mm-hmm.
Alcohol in water. So alcohol, like ethyl alcohol, you must be knowing, that is the those who are the liquor drinking, those whoever drink the liquor, na? What
Yeah,
they
yeah,
do?
yeah.
The water, they mix the water. Okay, so
Mm-hmm.
that become the homogeneous mixture. Getting my point?
Yes.
Now, what kind of here is the NaCl in water? That is what kind of attraction is there? Last chapter you study now, iron. This is the Na plus
And dipole.
and dipole. Thank you very much for recalling the ion dipole. Now, alcohol and water. You see the alcohol and water. Next space I am taking. Here is C2H5 and here is OH. This is what the drinking alcohol. What the people are using now, that is the alcohol. Okay. Or you are taking the syrup. Have you seen the syrup? Na? Syrup. So syrup, in the syrup,
Yeah.
mostly alcohol is there. Alcohol and water is there. So this now
Mm-hmm.
what is happening? What is happening? I am taking the water molecule. See here, O. Here is H. Bent shape will be there. Okay. If you study chemical bonding, you must be knowing, because here is lone pair electrons are there. Here is also lone pair electrons are there. Can you guess why lone pair electron I am mentioning here?
Uh,
Hmm. Single bond, sorry, single bond is equal to 2 electron, right?
Two electrons. Yeah.
1 electron of hydrogen, 1 electron of oxygen. Now see, oxygen is having total valence electron how many? Two
Oh,
and
so it has eight, so you need two lone pairs because
so
the bonds
so
that forms are
mhm.
two.
two electron in bond formation with two hydrogen. 2 electron bond formed. You know, bond formed.
Mm-hmm.
2 electron bond formed with hydrogen. Two hydrogen with two hydrogen. How many left? Out of six, how many left? Four
Four.
left, na? Four left. So each case here will be the four. So it is lone pair. So by the way,
Yeah.
let us go. What will happening, Jana? Sorry, here this hydrogen is going to form. What kind of bonding it is going to form? Oxygen and hydrogen. What kind of
Hydrogen bond.
hydrogen bond?
Hydrogen.
Yeah, great, great, great. This is going to be what? That is hydrogen bond. Okay. So that is hydrogen bond means completely it is going to mix. So this is now that is alcohol in H2O. That is what is this is example of liquid solution. Now gas in liquid. Let us move that is gas in liquid. So when you talking about sorry gas in liquid, which gas dissolve in liquid? Have you ever heard about that is fish are there, na? Fish.
Yeah.
So fish also because living the fish is living being. So it needs to survive. To survive, what is to survive? It needs to survive. It needs oxygen. Yes or no?
Yes.
So where in the fish stay in the water, na? Stay in water.
Mm-hmm.
Yes or no? So where they are
Yeah.
getting the oxygen to survive? The fish took what dissolve oxygen. Dissolve oxygen. Have you heard about dissolve oxygen?
So it is oxygen dissolved with hydrogen which
Dissolve
becomes
oxygen
water.
in dissolve oxygen. So that is O2 in water.
Yeah.
So if there is no oxygen in the water, now water will spoil. You know, water will be spoiled. A smell will come from the
Mm-hmm.
water, but there is the some amount of oxygen will be there. Okay. So here you see that is the next. That is so what the example will be here. That is the example of this is the example of this. These are the example of this. For this one example, if you are writing this one, that is gas in liquid dissolve oxygen dissolve O2 in water.
Mm-hmm.
Are you be able to understand this?
Yeah.
Okay. Can I erase this one or do you want to write this?
1 second.
Once, if you can write, that is very good.
Okay, yeah, I wrote this.
Okay. But in your syllabus, I think that is some less type have shown. Gas, liquid,
I
solid, liquid.
think they don't really talk about type. They go into talking about properties and strengths of solutions.
No, the various types of solution they have written here. Okay. Various
Okay.
type of
Yeah,
solution,
yeah, yeah.
but all okay. But if you are knowing this one, that will be okay now for you. It will be good
Mm-hmm.
only. Okay. If you are
Yeah.
knowing all the type, that is also good. They have mentioned 1 2 3 4 5 6 type they mention, you know, six type they
Mm-hmm.
have given. Okay, let us try to understand this one. Okay, now here is the solute, then again going to be solvent, then nature of solution and example. Nature of solution, and that is last one is example. Okay, let's see. If I am taking that is gas, okay, again gas, and here I am dissolving that is solid, then I am taking that is liquid and gas. Okay, अब gas in gas, if you are talking about this, all will be the gaseous solution. This all will be the gas solution. Okay, it is also will be gas solution only, and here also will be the gas solution. All will be the gas solution. Now when you are studying the example, then only you will be able to understand. See, gas dissolve in gas. Okay, gas in dissolve in gas. So mixture of air. Okay, this is going to be mixture of air. Have you heard about mixture of air?
Is it just different gases
That
mixed
is
with each
like
other?
N2, O2. This all get completely dissolved, na. In the atmosphere, this all the gases are there, na. And that is they are completely there. Gases get completely mixed. Like whatever we are taking here, we are taking that is oxygen. That's okay. But carbon dioxide also concentration is there, and N2 ammonia that is nitrogen is also there 79%. So equal
Mm-hmm.
concentration means they are completely mixing. Completely mixing means that is what is known as homogeneous solution. Are you be able to understand this one?
Yes.
So gas and gas, this is gas solution. Now if we talk about the liquid in gas, okay, liquid in gas. So where that is which liquid dissolve in gas? So if you talk about the chloroform, okay, chloro, chloroform, chloroform in liquid, chloroform in gas, chloroform mix in the gas. Okay, if you are talking about chloroform, so state solute, so gas in liquid, liquid in your was gas solid, gas liquid. Okay, so gas, next one is liquid gas. Let me check out the liquid and gas. Is there? No.
Mm-hmm.
In your syllabus, Liquid gas, they didn't mention. Okay, liquid gas. But here is the chloroform is the liquid, no? They mix together. Okay, chloroform is in the liquid form, they mix in the gaseous state also. So that is what example. Now you see that is solid and gas. Solid gas, if you are talking about, so that is camphor is there. This is the camphor. CAMPHOUR. Okay, camphor gets dissociate in the gaseous nature. Okay, so here if you are going, that is solid and gas. So here they have mentioned solid gas. Hydrogen in platinum, they are saying hydrogen gas in platinum. Solute.
Mm-hmm.
Wait. So gas and solid we need, no? Gas and solid. That is not correct one. Here if you are talking about gas. So in arts, in your syllabus, it is not there. Okay, they have mentioned only, but you keep in mind that is solid also. Solid means camphor is there, na? Camphor. So camphor get dissociate into what? That is a gaseous state. You know, camphor, if you are little bit heating, na, little bit heating, it also convert into what? Convert into gas. Have you seen the camphor? No, during
The
factory, yeah, people use. Hmm. So camphor
so
is having the unique property. What it is going to? It is going to mix in the gaseous state. Okay, directly convert. Camphor directly convert into what? That is the gas. Okay, sublimation process. If you are knowing. So
mm-hmm.
there is the liquid gas is there. If you talk about the liquid gas, so no, in your syllabus, these two are not there. They don't mention these two, and this they have mentioned. So let us try to move out. If you can make note of that is okay. Solid gas means gas solution. This is going to be gas solution. Liquid gas means gas solution. Gas
Mm-hmm.
means gas solution. Why they are making gas solution? That already I told you. That is if the phase of solvent is gas, so it is going to form the gaseous solution. Example I told you, the camphor in air. Camphor mix in air. That is first one. Camphor mix in air. That is example. Chloroform liquid mix in gas. Okay. Chloroform in air. That is also chloroform in air. That is the this is used as an anesthetic. Have you heard of chloroform? Earlier
Yeah.
time it was used as an anesthetic. So people, it was like that. We when we were doing the experiment, na, that is we are cutting the that one frog nervous system we were studying. So what we are using, we were using that is chloroform only. Nowadays chloroform is banned because of its toxic nature. So chloroform, if you are smelling the liquid of chloroform, na, it will, you will find something that is the your sensor will stop working. It means the liquid chloroform is getting dissolved in the air, so through oxygen, so that it is entering in our body. Now we are not drinking the chloroform, just you are smelling and you are feeling
Mm-hmm.
something. So your nervous system will small. Earlier time in the surgery, to do the operation, what we are using? Chloroform only we are used. Nowadays, so many anesthetics are being used. Earlier, chloroform was used. So that is what the camphor chloroform is also getting dissolved in air. So please do not get confused. Camphor in air means the solid camphor little bit you are heating room temperature. It will dissolve in
Yeah.
the air. Second word, chloroform is a liquid state. Okay. Chloroform means CHCl3. It also dissolve in what? Air. Chloroform mix in air. Okay. And last one, gas in gas, mixture of air. This is what the example. Can I change this one?
Yes.
Okay. Next one. Up six type total. We study six type. If you keep in mind the three type in the this one, this three types. Earlier three types, six type we study. Three more types are there. Okay. So I am taking now solid. Okay. Then it is going to be liquid, and last one is gas. Okay, this is the nature of solute. Okay, now we are going for the solvent. Solvent nature, if you are talking about, this will be the didn't study the solid, we are studying now solid. Here is solid.
Uh,
Okay, so firstly you pick up the solid. So it will, solution will be what type of solution? Can you please tell me type of solution?
so solid and solid will form solid solution.
Solid solution, thank you very much. So it will form, that is solid solution. Okay. So if you talk about the solid solution, can you guess the example? Can you guess the example?
A solid and solid solution,
Mhm.
like alloys.
Alloy. Oh, good, good, good. Alloys. Alloys means like the nickel is there. Okay.
Yeah.
Chromium is there and PT is there. Okay. Brass is example. BRASS. Brass.
Hmm.
Okay. So so many are there. So brass, bronze, there are so many. They are forming what? That is completely they are mixing in the solid state and forming the alloys. Are you be able to understand this?
Yeah.
Okay. Now liquid solid. Go further. Gas and solid.
Gas and solid will form a gas.
It is going to form a solid solution. It is forming solid
Okay.
solution. Okay. Solid solution. If you are talking about example na, so like hydrogen gas on PT surface, on PT, PT surface, platinum surface. Okay.
Hmm.
Hydrogen gas on PT surface, platinum surface. C student, that is the Soria. When you study in hydrogenation process, okay, whenever you will start organic, there it will be, you will be able to understand super hydrogenation process. It is used in the hydrogenation process. Example I am telling you, if you keep in mind example, suppose here is, it is tough to you to understand this method. This is the one molecule, here is the metal surface, this is the metal surface, and so many gases get adsorbed on the metal surface, so many gases. Okay, this metal is having a PT. If you are talking about PT, it is having 4 valency, free valency. So that is, here is what is H2 absorb, here H2 absorb, here H2 absorb, here H2 absorb. So what is happening, one of the hydrogen is getting add here, another hydrogen is getting add here, so it is forming CH3 and CH3, right? So what is happening,
Hmm.
where these gases are there, where these gases are there, on metal surface, on metal surface. So PT, that is hydrogen gas on PT surface. So this is H2 gas on PT surface, hydrogenation process. So process also I wrote here, I explained you no, hydrogenation means addition of hydrogen. Can't you understand this?
Yeah.
Okay. Now the last one is there, liquid and solid. Okay. So let us take that is liquid and solid. Sea water. They are saying sea water and sugar solution. They have the according to your book, that is it will be what, solid solution. Yes, solid solution. Why it will
Yeah.
be solid solution? Because solvent is this. They are saying what they are saying here. See. Example I am mentioning for this one, your book example, they are saying sea water, this is the sea water. Okay, and they are saying sea water is there, sea water, or also they are saying sugar solution, also they are saying that is sugar solution, also they are saying sugar solution. Okay, now you see this one, if you talk about the sea water. Okay, so solid in liquid. So a small amount of salt. If you see, have you ever taken bath in the during the beach? If you go in the Chennai, there is a huge big marina beach, or in the
Yeah.
Goa, if you visited here. So what there you will find, that is the too much water is there. Too much water is there.
Mhm.
And here they are saying salt is also there. Salt. But this is case of normal. But it is case of normal. But you know, I am changing the case. I'm changing the case. From where? From where? Salt prepared. So from where salt prepared? Tell me, from where salt prepared? So their concentration of water will be less, more, or the salt will be more. From where, that is like the Arabian Sea is there, or Bay of Bengal is there in India. We prepared the salt. Okay, so that is salt from, we prepared salt NaCl from the seawater only. Okay, seawater.
Okay.
So just I want to know, just I want to know which one will be more, salt will be more or water will be more.
Uh, the water will be more.
No, that is the where the wherever that is the, so we prepared a salty water. that is highly salty water, it will be salt concentration is high, salt is high. Solid,
Mm-hmm.
salt is high. Solid, salt is high. Okay, solid salt is high. And if you are heating this one solid salt, okay, solid will be more, salt will be more. Okay, so what is going to be if solid is more and sea water, especially the example is here, you see sea water we are taking where the salt is more quantity. Okay, and okay, and that is the water is less quantity, water is less quantity. Salt means all the places normally you cannot take only the sea water. I'm not taking normal water. If you are taking na normal water, so it will be home, it will be the home, but it is they are saying sea water. In the sea too much amount of salt is there, salt, even the mountain of salt is there. Okay, too much salt is there. That is what is they have given in your syllabus. They have sea water, that is sea water means solid in liquid. So solid salt in liquid, solid salt more in liquid. So like that they have said in your book. So little bit in your book now that much recalling is not given classification. So till now the we study this one, you keep in mind that is that it is possible that liquid can be less and solid can be more, so that we can take out the solid salt na. From there we take what solid salt. So solid salt how we are taking in home, we are taking salt in totally solid form. How? Because we evaporate all the liquid, only salt is there. How we evaporate? Because liquid is less, salt is more. Okay, so that become the solid. If suppose if the liquid is more, salt is less, so how much you can evaporate? It is too difficult to evaporate too much water, right? So that is
Mm-hmm.
keep in mind, it is also that is small liquid is dissolved in the solid salt. So this is what type of solution will form solid solution. Example seawater. Okay, will it be clear, Sorry?
Yeah.
Okay, so we'll be explaining you again. I will explain you little bit. If any confusion is there, na, the same mail, use the same mail and just put your problem. Okay, just
Sure.
type, sir, this is the problem. I read out this concept. Is it okay or not? The same mail you can use for a communication also. That I'll
Sure.
explain. Okay. Now next one, concentration of solution. Concentration of solution. Concentration of solution. So if you talk about the concentration of solution, that is the molarity is there in our syllabus. That is first one is something molarity, you know, molarity.
Mm-hmm.
Okay. So another is also there. Another is term is there, mass percent, mass percent. Okay. Then next one is there, mole fraction, mole fraction. Okay, mole fraction. So firstly let us try to read out these three, then we'll go in IB na, that is
Mm-hmm.
the in IBUS there are the 7 concentration terms are there, but in AP curriculum that is less are there. But you may be studying, see what the you have the opportunity with me, you read some other book also, whichever. Okay, you try
Okay.
to solve the problem papers also, previous year paper. You face the problem, you think that this is not taught, immediately you send to me, I'll teach you again. Okay, in the next class
Sure.
immediately. So that is what. Otherwise, if I will give my side, na, like I was explaining the 9 type of solution, that is not required. Even
Mm-hmm.
I teach that is types of intermolecular forces, little more I teach. So that is not required. You read also. So I am not giving you much quantity which is not required. You can think that is differently. So I am giving you what is given in your book. Okay, that I am explaining.
Okay.
And if anything extra you want, please let me know. No, please
I
let me
will. I
know.
will.
Okay. So molarity means capital M. Mole fraction means is it is represented by X, also known as chi. Okay, and no, mass percent means there is no symbol for mass percent. Mole fraction is X. Okay, this is X. So first of all, we are going to study the molarity. Okay, so let us try to study the molarity. Molarity. I'll share the problem based on molarity to you on your mail ID. Okay, so you try to
Okay.
solve molarity. It is number of moles. It is number of moles. It is number of moles dissolved in. It is number of moles dissolved in per liter of solution. Okay. It is
Okay.
number of moles of solute. You can increase a little its statement. It is number of moles of solute dissolved in per liter of solution. This is what our heading. It is number of moles of solute dissolved in per liter of solution. Okay. Means that is what we have to keep in mind. That is capital M is equal to number of moles. Number of moles of solute, number of moles of solute divided by volume of solution in liter, volume of solution in liter. Okay, so this become total as a whole, it become moles per liter, or capital M is equal to small n upon VL. Okay, this is so small n is equal to number of moles. This is going to be what?
Yeah.
Number of moles. And VL means volume in liter.
Mm-hmm.
Volume in liter. Okay. Capital M means what? Molarity. Can you understand this one concept of molarity? It is number of moles of solute dissolved in per liter of solution. Keep in mind, it is
Yep.
not solvent, it is solution, right? Can you please make a note of
Mm-hmm.
it?
I
Okay.
number of moles of solid is on a per liter. Yep.
Okay. So let us try to, I am giving you the problem. Steps. Steps to calculate. Steps to calculate. Step to calculate molarity. Okay. Step to calculate molarity. Okay. So what are the steps you are going to use? Very simple step. Step number 1. Okay. Calculate molar mass. No. Calculate molar mass. Calculate molar mass of solute. Calculate molar mass of solute. They are saying first. Step number 2. They are saying step number 2. What we are going to do? Calculate molar mass of solute. So what the second point, if you are talking about, what is the second point? Calculate number of moles. Calculate. Any idea about calculate number of moles? Any idea how to calculate number of moles?
We just take the given mass divided by the molar mass of the.
Yes. Calculate number of moles by formula given mass upon molar mass. Step number 3. Step number 3. Okay. Divide. Okay. Divide the moles with volume in liter. Moles with volume in liter. With volume in liter. You know, volume in liter. Now see. Suppose if volume in ml, if volume in ml given, if volume in ml given, so what you will do, Surya? What you will do? If volume
We
in
convert it to liter.
volume in ml given, so how you will convert?
Divided by 1000.
Convert in liter. Convert in liter by dividing with 1000. So already you know. I think what I find that is you know too much things you know. Let us try to solve. Okay. By the way, let us try.
Sure.
Calculate the molarity of calculate the molarity of what you are going to calculate, molarity of NaCl. Okay, NaCl. Don't take NaCl. NaOH. NaOH solution. NaOH solution dissolve in 40 liter 40 liter of solution. Okay, if the given mass is, if the given mass is, if the given mass is, how much they are saying, if you are talking about given mass, so you can take that is given mass is 40 gram. Okay.
Gram.
Hmm.
Okay.
Now you can make out the option also. You can make out the option. How can you be able to make the option? Hmm. Okay. Wait. Here option. I'm checking it. I'm telling you the option. Oh, so one. It is there. 0.025 molar. Okay. B number 0.045 capital M. 0.05 capital M, and D number none. They are saying NONE. Sorry, let us try to solve it out. Okay. So
Okay, so first I will find the number of moles of NaOH,
hmm, hmm.
which
Then
is going to
volume already
be,
there in the liter.
yeah,
So number of moles of what? NaOH. So it will be what? Given mass, already you told me, upon molar mass. So given mass is there, something is 40, I think given. Molar mass
yeah,
is given. Sodium is how much? 23. Sodium is 23 and hydrogen is 1. Oxygen is 16.
16,
Total how much is coming? You check.
40,
40 is coming or 46 is coming?
yes, 40.
40. Then okay. Okay. Yeah, correct. 40. So it is 40. That is also going to be 40. Means it is coming 1 mole.
Mhm.
1 mole. Okay.
And then we
So,
just do 1 divided by 40, so that gives us 0.025.
so molarity is equal to 0.02. So this is the very basic problem. Okay. It's okay. Can I erase this?
Yeah.
Okay. Question number 2. Calculate calculate molarity of, okay, 49 gram of H2SO4. 49 gram of H2SO4 dissolved in 49 gram of H2SO4 dissolved in where they are saying 500 ml of water. Sorry, so molarity they are asking. Okay, you please try to solve this problem.
Yeah, I got my answer to be one 1 mole per kilogram.
Okay, mole per liter. It will be the
Oh,
liter,
sorry,
no?
mole per liter. Sorry, sorry.
So you got that is molarity is coming one, na?
Yeah.
Okay, very good, very good. So it's okay. So I'll share you the problem, little tough problem. I'll share you. Okay, by
Mhm.
the evening time I'll share, na? Okay.
Sure.
Okay. Now let's go for the okay mole fraction. Mole fraction. Mole fraction. So mole fraction that is represented by chi. Okay, that is, yeah, you can see this is x. Okay, so what is
Mhm.
mole fraction, Sorya? Can you tell me mole fraction? Have you heard?
Yeah, so I think mole fraction is
Hmm.
kind of like the it's like the ratio between like the total number of moles versus the mole of the solute.
Very good, very good, very good, very good, good. Okay, mole fraction. Okay, let us say it is the ratio of moles of one component one component. It is the ratio of moles of one component in bracket solute, okay, with
Mm-hmm.
with total moles. It's going to be total moles. Okay, it is the ratio of moles of one component in bracket solute with total moles in bracket solute plus solvent. This is solvent. Suppose if I am writing, if we are going to calculate this one, mole fraction of solute. How to calculate mole fraction of solute? Mole fraction of solute. So what is mole fraction of solute? That is going to be moles of solute. Okay, moles of solute divided by total moles. Total moles, right? Total moles, or here is the mole fraction of solute. Here I am writing mole fraction of solute. Mole fraction of solute. So what is the mole fraction of solute? That is what it is going to be. Moles of solute. You can write moles of solute. Okay, and when you are dividing this one, moles of solute, so what will be there again? Total moles. How to calculate? So moles of solute plus moles of solute
Moles
plus
of solvent.
moles of solvent. Okay, moles of solvent. Is it clear?
Mm-hmm.
Okay, so now let us go for the next page. I'm taking if, okay, a and if a is what the expression is there. If a is solute, if a is going to be solute, b is going to be solvent. Okay, solvent.
Mm-hmm.
So na, what we can write, this is na is moles of solute. Yes or no? Moles of solute.
Yes.
Okay, and nb you are going, that is moles of solvent. Moles
Yeah.
of solvent. This is the second point. Now this is so 2 point you wrote, moles of solute, moles of solvent. Now we are going mole fraction of, second point we are talking, mole fraction of solute. How to write that is mole fraction of solute. Okay, so mole fraction of solute we have to write that is xa. I know mole fraction means xa. Mole fraction of solute means that is xa. Okay, so how we can write that is moles of solute, that is Na divided by total moles, that is Na plus Nb. Yes or no?
Yes.
Okay. Now the note is there. Note there saying sum of mole fraction. Sum of mole fraction. Sum of mole fraction is always one. Sum of mole fraction is always one. Sum of mole fraction is always one. Got it?
One.
Sum of mole fraction is always one. So moles of, if you are calculating solvent, moles of solvent, so what will be, that is 1 minus moles, mole fraction. Okay, sorry, mole fraction of solvent. How can you calculate? Anything you can calculate. If mole fraction of solvent, 1 minus mole fraction of solute. Mole fraction of solute.
Mm-hmm.
Hmm. So if you are able to calculate the mole fraction of any of the component, suppose Xa you calculated. So you know Xa plus Xb is equal to going to be 1, right? So
Yeah.
Xb is equal to, directly you can calculate 1 minus Xa. This is short trick. Either you can calculate, that is Xa you calculated. So another method is like that, Xb is equal to what, it is going to be Nb upon, it is going to be Na plus Nb. This is the one method. Okay,
Mm-hmm.
this is one. Another thing is there, you can calculate any of this, then you subtract from -1. So you can easily get this one, the value of the another one. Getting my point?
Yes, yes.
Okay. So let us try to solve some of the problem. Okay. Okay.
One second,
Cal-
could you just go back to the last one? I just had to note one thing down.
Okay. I'll share, surely I'll share you the problem. Okay. Today I am
Sure,
not.
sure, sure.
Today I'm not doing. Actually, I total from the morning I'm traveling only. So
Okay.
So I didn't bring anything. I don't have anything here. So evening time when I'll reach, I'll give you the problems. You try to solve that problems.
Sure, no problems. Okay, I noted it. Thank you.
Okay. Calculate the mole fraction of. They are saying calculate the mole fraction of, okay, H2. Okay, in solution of, they are saying in solution of H2 and N2, H2 and N2, where where the mass of, they are saying, where mass of H2 is, 4, and mass of N2, is how much they are saying, that is 28. You keep 28. Okay, so mass of H2 is 4 gram and mass of N2 is 28 gram. So they are saying that is mole fraction of H2. They are calculate the mole fraction of H2 they are asking. Okay, this thing.
H2, okay.
So option they have given. You please try to solve it out. I am writing the option. Okay, I am checking the option. Not checking.
Yeah.
Calculating myself that what can be the answers. Oh,
So this will just be 4 over 5. So this will be 0.8.
no, they are not moles. They are the given mass. They are gram. You
Okay.
need to calculate moles. You
So
need to
this will
calculate moles.
be. Oh, okay, okay. So this will be
Yeah,
2
yeah.
mole,
So
2 moles, and 1 mole. So this is 3 in total. So this will be 2 over 3.
you tell me in the fraction point.
0.66.
Oh, super, super. So already you are very brilliant here. Your calculation is nice only. It seems that is it's nice. Okay. So this is the answer. So okay, the tough problem will take little bit time, but now you are getting very easily. Okay. Now next one. That is there is mass percentage is there. Mass percentage. Mass percentage. Okay. So mass percentage means mass of, simple I am writing the formula. Mass percentage means me any of the component you can see, that is mass percentage of anyone is they are asking mass percentage of, suppose they are asking solute. Okay, so how to calculate? Okay, so that is mass percentage. I'm writing mass percentage of solute. So very simple will be there, what mass of solute is going to come, mass of solute divided by what is, that is total mass. Okay,
Total mass times
total
100.
mass multiply by 100. So nothing is there here in this one. Okay,
Yeah.
mass percentage of solute, that is simply you can calculate. If I am giving you the question, okay, 10 gram, okay, that is generally what is there. Sorry, let me write this one definition also. Okay, that is the mass percentage. These are being used in the medicine. In the medicine, when you are that is what component are there in the how much fractions, how much percentage there. That is the it is the mass of, it is the mass in gram of, solute. They are saying mass in gram of solute dissolve in, is specified, dissolve in specified amount of solvent, a specified amount of solvent. Okay, it is
Okay.
the mass percentage in gram, mass percentage in gram, okay, of solute dissolved in a specified amount of solvent. Generally it is there 100 gram. Okay, this is generally it is said that is 100 gram. A standard is 100 gram, but in calculation purpose you can, the question in question it can be given anything, but generally it will be 100 gram. If I am going for the questions, okay, let us try to write the one question. 10 gram, 10 gram chloroquine, 10 gram chloroquine, okay, to 10 gram chloroquine is dissolved in, it dissolve mean 90 gram of dissolve in 90 gram of what? 90 gram of alcohol. Okay, in bracket syrup. Okay, then find the mass percentage of chloroquine. Option A they are saying, option A 10%, option B they are saying 20%, option C they are saying 0.99%, option D they are saying 1.1%. Tell me the answers.
I think this is going to be 10%.
10%, yes, yes, yes. Because mass percent of solid, if you are calculating mass percent of chloroquine. Chloroquine. So that is mass of chloroquine. This is mass of chloroquine. Okay, divided by total mass. Okay, total mass and multiply by 100. So mass is how much? Mass of chloroquine is they have given 10 gram. Total mass is 10 gram plus 90 gram. Multiply by 100. So simple, it came 10 upon 100 multiply by 100, 10 cancel out. So 10%. Got it?
Yes.
Okay. So sorry, for today, I am leaving you here. Sorry, extremely sorry.
Yeah,
Okay.
no
So
problems.
the next class onward, whenever the next Sunday, next Sunday will be on time. Okay. And we'll be
Sure.
teaching you the properly whatever the concept are coming at the forward. This is a very
Okay.
easy that is, and very interesting. When you go move downward in the book, na, this chapter, deeper concepts are
Mm-hmm.
there. So it will be enthalpy are also there. So it will be very interesting. So we'll be studying on the next Sunday. Yes, na?
Yeah, sure.
Okay, okay. So for today, okay, bye. Take care, na?
Thank you.
Okay.